Hi folks, today we're going to work on solving quadratic equations, and we're going to do this by factoring, which we just got done working on. So we're going to stay with factoring for quite some time, so we might as well get used to it. So there are different ways that you're going to see these directions, or you're going to hear the directions. One way would be to just solve the equations. Another way that it might be stated would be find the roots of the equation. Another way yet might be find the zeros of the function by rewriting in intercept form. They're all saying the same thing. The roots, the zeros, the intercepts, all saying the same thing. Now, one little precursor that we got to make sure we mention is when we're going to solve these quadratic equations and functions, we need to make sure that they are set equal to 0, because basically that's what's happening, is you're figuring out what x is when y is 0. So your graph will look something like this. So you're figuring out where your graph is crossing the x-axis, and at that point in time y is 0. So we're going to set y equal to 0. So we want to make sure our quadratic equation is equal to 0, and it will also help if you have a positive x squared term. The reason it helps is it helps out with those factoring rules that we learned the day before. So we can start out here with x squared plus 3x plus 2 equals 0. It's in the proper order from the squared term to the single x term to the constant, and it's equal to 0. So we're pretty much ready to go here. So we can write out our two blank sets of parentheses once again. And since we have plus plus for our signs in the quadratic, we'll have plus plus in our binomials. The x squared breaks down into x and x, and the 2, remember, we can break that down into 1 and 2, and 1 plus 2 does give us that middle term of 3. So now it's still set equal to 0. So our next step in this, very simple, is just to set each binomial equal to 0. So we have x plus 1 equals 0 and x plus 2 equals 0, and now we just solve for x. So very simple, extra step on the stuff you've already done. So here x would equal -1 and x would equal -2. So this graph of this parabola is going to cross the x-axis at -1 and -2. Over here on the right we have another example, but as I stated earlier, we want to make sure that we set it equal to 0 first. So we want to take this 24 and subtract it over to the other side. So now we have x squared plus 10x minus 24 equals 0. So now we're ready to factor this apart, and since we have plus minus as our quadratic equation, we can have plus minus in our binomials. So now the x squared will break down into x and x, and the 24, the factors of 24, there are a lot of them. There's 1 and 24, 2 and 12, 3 and 8, 4 and 6. So since we're looking at opposing signs here, which pairing will give us a difference of positive 10, and that's going to be a plus 12 and a minus 2. So this pairing right here. Now we just continue on with our next step like we did before. Set each part equal to 0 and solve from there. So here we would subtract 12. So x equals -12, and here we would add the 2, so x equals 2. So this graph would cross the x-axis at 2 and -12. And if you think back to when we worked on graphing these using intercept form, you can now take just about any function as long as it's factorable and put it into intercept form where it's fairly simple to graph it. So here we have a couple more examples. We can work through these real quickly. Again, we have this first one, x squared equals 2x plus 48. We want to make sure we set that equal to 0 first, and we want to make sure also that we have a positive x squared term so that our rules will continue to work. So we're going to subtract the 2x and the 48 over to the other side. So we'll have x squared minus 2x minus 48 equals 0. So minus minus will give us signs of plus minus in our binomials. And now we can start factoring it apart. So the x squared breaks down into x and x. And the factors of 48, here again there's a lot of them. And we're looking for something that has a difference of -2 since we have opposing signs. And that is going to be a plus 6 and a minus 8. So now we can set each part equal to 0 and solve. So we'll figure out the roots, the zeros, the intercepts, all the same thing. So x would equal -6 and x will equal positive 8 by getting x alone. Last scenario, right here, we're given f of x equals x squared minus 2x minus 15. Remember that f of x is the exact same thing as a y, and we're turning all of those into 0. So we have 0 equals x squared minus 2x minus 15. So again, we factor that apart. The minus minus gives us plus minus. The x squared will break down into x and x. And the 15, just a couple of factors there, either 1 and 15 or 3 and 5. And again, since we have opposing signs in our binomials, that will be a plus 3 and a minus 5. So now we can set each of these equal to 0 and then solve for x to figure out where it's crossing the x-axis. So it's crossing at -3 and it's crossing at 5. Okay, your assignment is page 256, numbers 25 to 55 odd, skip number 43, and then 65 to 69 odd. We'll see you in class. Good luck.